This is Professor Geisler at Cosumnes River College, and this is your short video lecture on Section 2.4, Hyper-V on Windows Client for CISN 301, using the TestOut version 8.0 environment with Windows 10 and 11. And we're finishing this chapter with Section 4 about Hyper-V. We'll take a look at how to use Hyper-V. We're going to add a virtual hard drive to a virtual machine so that you've got basically a place to store something that feels like a hard drive in one file. It's kind of cool. Um, you can create and manage checkpoints, which basically allow you to uh, take a snapshot of a VM and bring it back to that state. And then we'll uh, briefly talk about Windows Sandbox as well, which is for all intents and purposes a disposable um, a, a virtual machine that you can use for testing when you are a developer, for example. So here are some key terms. We'll talk about those here in just a second. A hypervisor, as we've discussed briefly before, is software that allows you to share hardware across multiple different operating systems. Okay. And you can either um, have a level one hypervisor or type one, which is a uh, bare metal, sits right on the hardware type hypervisor, or what we're going to be more talking about in here, a type two, which is a host-based hypervisor, such as Hyper-V, which means that you have to have an operating system installed. And then from within that operating system, you are launching and accessing additional virtual machines. It's basically, I would say it's like running Windows in a window. Okay. And that's what a hypervisor makes possible. You may have heard of other hypervisors such as VMware, for example, and there's some uh, open source varieties as well, such as VirtualBox. Okay, so different kinds of hypervisors. And what's nice about VirtualBox is you can use it on your home edition because the Hyper-V hypervisor does not come with the home edition of Windows 10 or 11. It only comes with Pro or better. Okay, what is a virtual machine then? A virtual machine is basically a an operation that looks like a computer that is not directly tied to a computer, but that uses some of the computer hardware that is allocated to it by a hypervisor. Okay, so uh, you can run if within your host Windows operating system, you can run another instance of Windows, or you could run Android, or you could run Linux, right? So when you boot your computer, you don't have to dual boot. You boot into your standard operating system, and then, assuming you've got enough hardware to make that happen, you will then use uh, VMs to run those other operating systems. Notice I didn't talk about Apple operating systems because, again, those are limited to run for licensing purposes only on Apple hardware. But of course, that doesn't mean that you couldn't buy an Apple computer by default, boot Windows on it, and then run an Apple VM. I personally would do it the other way around, but that's up to you. Okay, if you wanted to structure it that way. Um, but of course, you still have to get the license for Windows if you're running it on an Apple PC, because an Apple PC does not come with a Windows license. Host machines, if you have a hypervisor installed on a computer, that computer is the host. Okay, so you have a host machine, and then you have one or more VMs launched from that. And again, as I mentioned, the Windows Sandbox is basically a throwaway VM that's used for deployment purposes, or development purposes, I should say, for testing programs if you're a programmer, etc. So how does Hyper-V run on a Windows client? Well, let's first of all go back to the concept of virtualization and what happens when you virtualize, okay? Because what happens is that you have the ability to share the hardware that would be in a traditional model only limited to the one operating system that is on that computer. And you can now share that hardware across computers. Now, in the traditional model, you can have one operating system and you've got multiple applications on that operating system. That operating system controls all of the resources of that computer, of that hardware. Okay, all of the CPU, um, the storage, and the memory. Okay, now that is a certain, it's tradition, but it leads to certain inefficiencies. Because notice right here, we've got 3 physical servers, and the CPU utilization is less than 11% on all 3, which means that the rest of the CPU power is idle and really not being used. Okay. Well, you could have argued, well, why didn't they just, buy, servers with CPUs that were cheaper? And they could have, but wouldn't it be nice to have some flexibility, which frankly is part of virtualization as well. So let's talk about that type 1 hypervisor that Hyper-V is not. Okay. A type 1 hypervisor allows you to install that hypervisor on the bare metal, as it's called, on the hardware. So when your computer boots, it doesn't boot into an operating system at first, it boots into a hypervisor. And then from that hypervisor, you then select uh, between virtual machines that are running concurrently. And all those virtual machines are using some of the CPU power. And of course, these days with multi-core CPUs, that's pretty easy to do. Um, they use some of the memory, and that can actually be dynamically allocated and reallocated while things are running. And then, of course, on an existing hard drive, you can create virtual hard drives, which then are assigned to one of those virtual machines, so that one physical hard drive can be used by multiple virtual machines via that hypervisor. Now, a type 2 hypervisor, which Hyper-V is, okay, sits inside a host operating system, of course, in this case, Windows. And it is a piece of software that similarly allows multiple virtual machines to share the CPU cycles, the disk space, the storage, and the memory, and other resources, of course, of the physical hardware on which they reside. This is uh, an alternative where that most of us probably would use, where we do need one host operating system that we use for most things, and then we use VMs for certain things, right? Whereas the model, let me back up to the previous slide here. This model right here basically means that you've got 3 machines that are always going, okay, that are sharing that hardware. And of course, what's nice about this is that, as I mentioned, you can reallocate those resources. So if, the virtual machine over here running app 1 and 2 all of a sudden need more processor cycles, then I can actually allocate more of those cycles to that VM and just take them away from the other VMs. And I can do that on the fly. Okay. So that temporarily I can assign a greater, amount of resources to specific needs, which of course allows me to more efficiently use my hardware. So let's take that to the next level. Rather than deal with just one PC and servers, let's also talk about what's called VDI, or virtual desktop infrastructure. Notice what you're seeing here is a rack-mounted server, Okay, I'll make this a little bit larger so you can see this. And we can have multiple virtual desktops on this one rack-mounted server. So basically what's happening here is we've got one physical piece of hardware and multiple virtual desktops. And those desktops all use share the resources of that one server. Okay. A great example of that, by the way, is Cosumnes River College's virtual labs, which were created at the beginning of the COVID pandemic. And we've maintained them because they allow our students remote access to certain installations to which they would otherwise only have access within a computer lab. So with VDI, they can connect remotely from a weaker client. You can do this with a Chromebook if you needed to, with your phone if you really wanted to. Um, and you can run the applications that would be installed on Windows and on what typically would be a relatively oomphy kind of desktop computer. Again, virtualized as such. So to get to those VDI uh, clients, those desktops, again, you can, all you need, and those notes it says end user thin client. Basically, you're relegating the device that you're using to a terminal. I don't want to call it dumb terminal because it does have a local processor. But basically, it's a terminal that transmits your keyboard strokes and your mouse clicks, or similar kinds of signals across the network. And what comes back is an update of your screen because really all the processing is done on the VDI server's host. Okay. Um, Efficient? Yes. Are there some limitations? Yes. Anything that's relatively hardware dependent, such as graphics operations, for example, you are limited to what's on the VDI virtualization server. You can't, say, upgrade your video performance of a virtual machine that's running remotely by installing a better graphics card on your computer. Peripherally, but not too much. So there are some limits, but boy, it's certainly nice and easy to update those virtual desktops because you can turn them on and off and restart them when you want them, when no user is using them. Um, so that's a pretty cool way of maintaining control over your over the quality of your installations. Now, you can either have VDI on-premise, meaning you've got that server sitting in the same building where you're, or on the same campus where your client computers are sitting, or you can do it via the cloud. And of course, that's how CRC does it because you don't need to be on campus to be able to use the CRC virtual labs. And of course, um, that would be the third-party company in this case, right, for the cloud. But you can actually, quote unquote, rent cloud resources. Amazon Web Services is an example of an organization that would allow you to do that. And there's others like Google Cloud Services, and there's a Microsoft alternative as well. Okay. So let's take the virtualization one more level. So there's also something called a container. Now, a container is not a separate operating system, but it allows an operation to happen. So if uh, there's a dear friend of mine who at one point in time asked me, this is when Windows XP was released, way back when. And he asked me, um, Marcus, do you think that Windows XP is going to be the last operating system that Microsoft releases? And this is one of the smartest people I know. He was an economist for the state, highly intelligent man. I'm like, why would he ask that kind of a question? Because operating systems have always been Microsoft's cash cow. They make tons of money off the OSs. Why would they not release another operating system? But at that time, virtualization had already started to taking hold. And he realized that, and containers as well, and basically realized that, why don't we just run on, on a very basic operating system, whatever application we want in its own container? Okay. Or we could even, like in this example, throw a couple of apps into the same container. Um, they've got their own mini operating system to go with it for whatever they need, but they don't necessarily need anything big beyond the host. So you could run like an Apple app on a Windows PC, right? Or a Linux app on a Windows PC without having a separate VM. You could just do it within a container. Uh, we haven't gone to this very much. There are some web services that use the containers, um, so you do see it here and there, but this is certainly the basis for a lot of flexibility that would allow us to do all kinds of things. Now, what's stopping us? Well, humans are creatures of habit. Um, and we do like things that kind of work the same way. So um, when it comes to the uh, human interaction with computers, that flexibility may be underused for reasons that are not technology related, but more so human related. So here's the difference. Containers are very lightweight, smaller, they start up quickly, whereas VMs tend to be a bit more heavy. They are more portable, which means you can take them from one place to another, meaning you can make a copy of a VM and start it up someplace else. But there's the sacrifice that it's a little bit larger and it takes a little longer to get started than a simple container would. As always, make sure you do the labs, okay? Because in this class, you're going to learn how to create a VM. And you can't, in most cases, do that on your home PC because you don't have Hyper-V. Again, you can download VirtualBox if you want to do it in a competing product. It's open source. It doesn't cost anything, okay? And then you'll also learn how to create VHDs or virtual hard disks, which are basically just large files that behave like a disk drive. And I'm scared to say that I've seen VHDs substantially larger than the hard drive of the first computer I ever bought, which was a 40 megabyte hard drive. Yes, way back when in late 1989. So go through those labs so that you'll know what's coming. And then last but not least, I think we've you know answered several of these questions, but we haven't answered the first one. How can virtualization help you provide legacy software to users? Well, legacy means old, right? So let's say we're upgrading to Windows 11. We're forced to upgrade to Windows 11 because that's what Microsoft is going to support after October 2025. But I've got applications that need to run under, say, Windows 8 or Windows 10. Can I still allow those to run? Of course, accepting the risks that come with operating systems that aren't being updated anymore. And the short answer is yes, you can run a VM with one of those older versions of Windows. Yes, you're going to have some issues when it comes to protection, um, because those VMs do independently interact with other resources across the internet, so you can only protect them so much, and those doors would be open. Um, but yes, you can actually keep old software running. And actually, Microsoft's been pretty good at that for quite some time because they've had DOS virtual machines inside Windows for a long time, up until recently. So in theory, you could have written a program, uh, in the 1980s and still run it here until a few years ago within a virtual machine within Windows. I think we did address what a hypervisor is, so I'm not going to go back into that. And how do you enable Hyper-V in a Windows environment? Well, you start it. Okay, so it's a tool that you can start a service technically, but yeah, start it up, and then you can create virtual machines from there. All right, so much for section 4. That does finish chapter 2, Windows installation. So at this point in time, you should be a whole lot smarter about the versions of Windows, how to install them, and many of the details and tools that go with that. Make sure you work through the environment in TestOut, and then you can move on to chapter 3 after this.